Ayati, and this is my Lab 4, Physics 1. So, introduction, the purpose of this, we want to use a spring and a mass system to observe the energy principle. First, we're going to do tracker to observe the real motion of the spring, and then we're going to compare that to code that we're going to make in GlowScript. So, some of the fundamental physics principles that we'll be using, you're familiar, Newton's second law, and we use that to derive our velocity update formula. Some more fundamental physics principles that we're going to use, the spring force, which we have over here, and the energy principle, where change in energy of the system is equal to the work done by the surroundings. And a couple more formulas that we're going to use. We have our kinetic energy, which is over here. We have our gravitational potential energy, which is right here. And we have our spring potential energy, all of which will be used in this lab. Now, to define our system and surroundings. So the system, in this case, is just going to be the mass, the spring, and the earth. And our surroundings is going to be nothing else because we're including the earth and the spring in our system. So in the experiment, you can see here, we have mass attached to a spring, and it's going to be held here, and it's going to be released from rest. It's going to oscillate back and forth in a motion like that. Now, the initial conditions that we used for our code. We were able to find the mass of our ball up here, and then using the tracker, we were able to find the initial position of our mass here, and using delta t and our first points, we found the initial velocity of the vector. And then down here, gravity is 9.8. To find the spring constant, we did this formula over here, where t is the period. And then L naught, the relaxed length of the spring, was given to us. So here's more of what the code will be doing. So to figure out like where the spring is positioned at, you have this here where you're finding L hat, L, and S. And then we're here defining our energies. So kinetic energy is just going to be 1/2 mv squared. Gravitational potential energy is mass times gravity times delta y. Potential energy is 1/2 ks squared. And then our energy is going to be, the total energy is going to be all. And then we're going to move into our for loop, so it's going to calculate it a bunch of times. We're defining these up here. Our initials up here. Gravity is just the mass times gravity. And then calculating your spring force again. Calculating your Fnet. Doing your velocity update, your position update. Updating the spring position as it is over here. And then you're recalculating all your energies. And you're doing your final minus your initial. Oop. Let's go back. Anyway, so once we do all that, we get this energy graph, which makes a lot of sense because our total energy is 0 because energy can neither be created nor destroyed. We also compared what we had in our code versus our actual, which lines up pretty well with, a little bit of variance, which is expected because, tracker is imperfect. So what does it mean? In this lab, we did definitely see that our energy principle is satisfied. The change in the spring potential and gravitational potential energy are opposite to one another, which makes perfect sense because energy is not created. It's just moved throughout the system. So the sum of the energy is 0, and yeah, the energy principle states that the total energy must stay the same. And you can see that in this graph. As the spring is up, the gravity is the opposite, and your kinetic energy is just going to oscillate between. Finally, what does it mean? So our X position oscillation average was 1.61 seconds, and our Y oscillation average was 1.52 seconds. They're a little bit different from each other by 0.09 seconds, but it's not much. And that's to be expected because there's possible errors that can be occurring here. Most likely human error. Tracker is not perfectly precise. So when you're inputting those positions over and over again, it's going to make mistakes. Plus, air resistance is not accounted for, and there are other energies like heat and vibrations that aren't accounted for. That's it. Thank you.